Hello.
Good morning.
How you doing this morning?
Uh, kind of tired. I stayed up late because I had to watch a AP meeting and I had to make a PowerPoint and stuff. But
Ooh,
oh
that
well.
sounds very boring.
Yeah, scary kind of more than anything else.
What do you mean by scary? I mean,
Well,
is it,
because the AP test this year is totally different. It's going to be on the computer, and so it, you
well,
know, it means a lot to these kids because they want to pass it so they can get college credit, and so it kind of
that
scares
too,
me. Yeah.
but you're scared because you might end up, um, failing the kids or,
Well, yeah, I guess maybe that's the root of it, but mostly I usually I feel like I'm in control because I know what's going on. This time I feel totally out of control because I don't know what's going on.
oh,
And
you don't know because the coronavirus has
well, it's
messed everything up?
yeah, it's messed up how they're doing the test, and so I mean, usually I know the test is this amount of time. I know it's these types of questions, and so I know how to prepare the kids. But this year it's totally different, and so that kind of
Oh,
scares me a little bit. So.
um, shouldn't everyone else be in by now? I mean,
Uh,
everyone,
I'm going to give it another minute or so, and then I'm going to tell you what we're doing today, and then you're just going to start working on the practice quiz. Oops, here comes another person.
okay.
Wait, I already did.
Look at me, I'm upside down.
Hey guys, upside down.
Okay, I'm going to go ahead and start sharing my screen with you. Um, okay, so today we are doing kind of a practice test because next Monday is going to be a real test on the computer. And so there are 14 questions on today's practice test. Um, and let me go to Wednesday. It's Wednesday. And you'll click this link here. It says balanced and unbalanced force review. It's already open. You could have started it already. As soon as you get at least 12 right, you're kind of done. You can ask questions if you want, and I'm just going to be available to come in. And if you have any questions, there should be a way in the breakout room where you can call me. I don't know because I can't really see it from your end.
Yeah, okay, so in the breakout room, it says, ask, there is a way to call you. So
Okay, right.
it's, so once you get into the breakout rooms, it's like, there's this thing like, ask the instructor in question or something, or,
Right.
yeah, it's something like that, but there is a way to call you. There is a way to call you.
And so that way you could just call me if you have a question, you don't understand something, and I thought I could come in. All right, so I'm gonna go ahead and open up the breakout rooms to kind of make it so you guys are able to kind of work quietly. You're actually going to be by yourself in the breakout room though this time. That way, you're not going to have any disturbances or anything, and you're just going to click on that link. Maybe I should share again because some people we're having a hard time getting in. Today, if you let me go to the calendar. If you go to the calendar and you click on the agenda, let me get rid of this, and scroll down to Wednesday, all you're doing is you're doing a practice test, kind of a practice run of Monday's test or quiz. And as soon as you get 12 out of 14 or better, you're done, and that's it for the day. And so you're going to click on this and do this quiz. And if you need help, you can call me. Okay. So let me go ahead and open up the breakout room so you can go on in there. Okay, and then you just work on that practice quiz. Call me if you need some help. think I need to get some new batteries. If that's any better or not. Hi, Josh. You want to share your screen with me at the very bottom? Hit share screen.
Yep.
Yeah.
Oh, share your screen. There you go.
This one?
Yep. Can you speak to him now? Tell him what we're asking.
Oh, okay, perfect. Okay, so for this one here, we're trying to figure out what that force is kind of upward and to the left, right? The slanted one?
This one right here, Josh. See what he's talking about?
Yeah.
Okay, so do you have a piece of paper?
Yep.
Where are you
Okay.
done with, where are you done with
You're
this?
listening because you got this wrong.
Okay,
So he's going to help you.
so what I need you to do is, if you look at the picture there, can you see that one over up to the left is kind of making a triangle? And so that up to the left, that's kind of the hypotenuse of the triangle. Can you make a right triangle such that it kind of looks like that? Can you imagine a triangle there?
If you put this, see if you put this line right here, you, sorry, if you put this line right here, he's telling you you'd have a triangle. Do you understand that?
Yeah.
So what I need you to do right now on your paper is, can you draw that triangle that kind of looks like that?
Okay, see how he's drawn that triangle right there? You following him, Josh?
Yeah.
Okay, so do you have it? Do you have the triangle drawn?
Yeah.
Okay, now you kind of need to look at me for a second. Can you look at me? At the
Look at him. Look at him. Look at him.
So your triangle, in fact, let me draw on a piece of paper. Does your triangle kind of look like, does it kind of look like, I don't know if you can see that. Does your triangle kind of look like this, except it's backwards, I guess?
Actually, it's that direction. You're
Okay, okay. So what you need to do, Josh, can you look at me?
Look at him.
Yeah.
This vertical part right here, can you make that 7, please? Make that side 7.
Right, that side has a 7, Josh. Right here.
This one?
Yep. Go ahead.
Okay, and then make the other side, can you see right here? Make
Look at
this
him.
side,
Look right here.
make this side the other length. What was it, 5 or something? It's hard for me to see.
Yes.
Yes, it's 5. Make this side 5. Okay, how do you find this hypotenuse here? Do you remember what equation helps you find the hypotenuse?
Mm,
You remember?
I'll give you a hint. It has something to do with c squared.
A squared must be B squared equals C squared.
There you go. Josh, this is what I need you to do. Can you look here?
Look up.
Yeah.
Right here on this side right here, can you please put a C, put the letter C?
Yeah.
And then the other side, make this A. Can you see right here? Make this side here A,
The other one B.
and the other one B. That's right. So now write the equation A squared plus B squared equals C squared. Okay, you got that?
Almost.
Okay.
Okay.
Okay, now for the A, go ahead and put 5. So it's going to be 5 squared.
What's
For B, put 7 squared.
and you don't know C word.
And you got to solve for C. So you think you can do it?
Yeah, your calculator.
Calculator. Sorry.
I have a calculator here just in case.
So Josh, Kari asked me to come join him. Can I have you work on that problem, and then I will come back and see how you're doing?
Yes.
Okay. Thank
Okay.
you.
Thank you.
Okay, yep. All right, Kari, it took me a while. I was helping Josh out. Can you share your screen with me so I can see your screen?
Okay, so I'm just having trouble answering like some of the questions.
Okay, so let's see. What does the word normal mean? So like a normal force. Do you remember what that normal word means?
Isn't it?
It's a math word. It has something to do with some angle.
Oh, perpendicular.
That's right. So it's perpendicular. Let's read. A component of the force exerted by the surface. Yeah, that's it. Looks good to me. Yep.
And then force arises whenever one force or one surface makes contact with another is always perpendicular to the surface.
So what do you think?
So Fn.
Yep.
And person pulls a rope attached to the object at angle. The object moves across a frictionless surface. Which of the following forces acts on the object?
Okay.
So-called butterfly.
Okay, so we need to figure out what forces act on this. So if you look at the picture there, that upward kind of arrow is supposed to be like a rope or something, and it says it's frictionless. So if you're going to draw a force diagram, what forces would be acting on it?
Tension because it's a rope, right?
Absolutely, check that. Yep. What other forces?
Well, weight because
Yep.
it's the object,
Yep,
and then normal.
that's right.
All right.
There's no friction in this case because it says frictionless, so that's
Yeah.
it. Those three.
Mhm. Which of the following free body diagrams best represent the free body diagram? Which, with correct relative force magnitudes of a person in an elevator that is traveling upward with constant velocity. FF is the force on the floor and the person.
Okay.
In the option.
Okay, so it says it's like an elevator and there's two forces on them, FF from the floor and there's FG, okay? And the key word here is it says constant velocity. Doesn't it say that? Yeah, constant velocity. So I have a question for you. If it's constant velocity, will it be balanced or unbalanced?
If it's constant, it'll be unbalanced.
No, constant velocity means balanced.
Oh, so
So look at the top
means-
one. Does that look balanced?
no. Mm-mm.
No. Does the next one look balanced?
Yeah.
Wait, they're both downward, right?
Oh yeah, never mind. I thought it meant they're both equal.
Okay, so the next one, does it look balanced? You got a long one up and a little tiny one down.
No.
No. How about the next one? Does it look balanced?
Yes.
Yep, I think that's it. I have to go help Imani. Can I go do that and then come
Yeah.
back here? Okay,
Yeah.
great. Okay, so Imani, sorry, I was hoping other people, can you share your screen so I can see which one you're having a hard time with?
Yes. I'm sorry. I'm kind of.
Do you remember how to share? Green button at the bottom, hit share screen, and then when a pop-up comes up, there's a blue in the lower right. Click the share.
Oh, okay.
Okay, so which one, number 11? Or is there another one you had a question on?
Yeah, number 11 and 12. I got stuck.
Okay, so a force of 120 newtons is applied to an object. Okay. Oh, so for this one, you have to use F equals ma. So do you have a piece of paper there? Right, F equals ma.
Okay.
And then plug in what the force was. It says the force is 120.
Okay.
And it tells you the mass. What's the mass?
30.
30. So how would you solve that for A?
Would I subtract 30
No.
from 120?
No, you got to divide.
So
it's gonna-
120 divided by 30.
That's it. Do you mind if I leave because some other people ask questions and then I'll come back?
Yeah.
Okay. So
Hi.
I was helping other people. Sorry, Noah. Do you
I
want?
know. It says that too. If the host is currently helping other people, it will say that.
Oh, good. That's nice. Okay. So at the very bottom, there's a green share. You want to share your screen, and then a pop-up comes up, the blue, hit share. That way I can see the problem you're dealing with and I can help.
Okay, so
Okay. So,
I got 13.5 out of 14. It's almost perfect score.
oh, that's good enough. All you had to do is get 12. You're doing great. But
Yeah,
these are
but
the ones you missed. Let's see.
I don't
Oh,
know.
okay. Here's the reason why you missed that one. It doesn't say there's a rope attached. So I don't think there's really tension.
Oh, so this is a pull force from
That's
a
right.
person.
That's it. Yep.
So, but there's 0.5, so that means it got one other thing wrong too. Got two things wrong, but so there's a pull force from the person. We got
Well, okay, here's why it's 0.5 is that in a way you kind of have two wrong here. You didn't check a pull force and you did check a tension force. So it's kind of like a double whammy.
oh, double whammy.
Yeah.
So if I do pull force from the person, check it, but don't check tension,
Yeah, that would have been
it'll be a 1 point.
yeah.
Ouch, that's a double ouch.
Yeah.
Okay, so but I know why I missed it. It didn't really say
A rope or
tension.
something. Yeah.
I mean, how did I? Honestly, I just YOLO'd this one. I just straight up YOLO two on that
Huh.
one.
Are you saying you don't know how to do it?
No, I was saying I know how to do it, but I didn't do it without actually doing any work for it. Kind of did it all in my head.
Okay. Yeah, I mean, that's the nice thing about the test on Monday. It's
Oh,
going to be on the computer. I'm not going to grade your
okay.
work.
But
Yep.
this is the one. This is the only one I straight up guessed on it.
Oh, well,
This
that
one I straight up guessed.
okay, so Noah, the way you do that one is you draw a triangle over there. Can you kind of imagine a triangle on the left-hand side? Okay, yeah, that was a triangle. And can you move horizontally? That horizontal move, that right there, stop. That is 5. Do you see how there's 5 on the opposite side? So it's 5 right there. Now go upward, go upward. That side of the triangle is 7. So
Okay.
imagine drawing a triangle where so can you look at me for a second? This side here is 7. This side here is 5. How would you find the hypotenuse? What equation?
A squared plus b squared equals c
There you
squared.
go. That's how you solve that one.
Okay. But I straight up YOLO'd it and I get 8.6.
Yep, you got it. Do you mind if I go help other people?
Yeah, sure.
Okay.
Okay, so can you send me back to the main session? I don't know what else to do since I'm done.
Oh, well, you can just leave then. If you're done, you can leave. I'm sorry it took me a while. I was helping other people. David, can you share your screen with me? The little green share and then the blue share?
Yeah, I just submitted my quiz and I did horrible. So
Sorry.
yep, it's all right.
I've been jumping around. I was hoping Mr. Alger would come and he could help it. He's probably tied up with other stuff.
Yeah.
So the green at the bottom share and the blue, or did you want to just? We could talk
I'm
about
just-
the one. We could talk about the ones you missed.
Okay. Hold on, let me get it.
Do you want me to come back later?
Yeah, let me find
Okay.
it.
I'll do that then. Jacob, sorry I was late, but I was helping other groups. Can you share your screen and I can see how to help you? The bottom, hit the share green, and then a pop-up comes up, and then hit the blue in the lower right, share. Okay, so which ones you want to look at? See, a block is, wait, well, let me look at that one. Oh my gosh, you shouldn't have got that one. I thought I got that. That's my bad. So ignore that one. Don't worry about that first one. That should not be there. That's my bad. That's a bad question. So scroll past that one. This type of force prevents the slide. Yeah, that's right. You're doing good. Okay, now wait a second. Normal force is, remember the word normal means 90 degrees or perpendicular. It has to have, can you look at my hand here? It has to be like, imagine this is a table. It has to be something touching, okay? So there's nothing touching here. So, but there is a force. Look at this. What, I mean, you're on Earth, right? So what force would be on this?
Maybe tension? No.
There's no rope. There's no rope on this. There can't be tension.
Weight, right?
Yeah, there's weight. Exactly. There's weight. Force of gravity. There you go. Okay, so the key word on this one is, it says constant velocity. So I have a question for you. If it's constant velocity, will it be balanced or unbalanced?
Balance.
That's right. So I want you to look at the one you selected. So the one you selected, does it look like those are the same length? Do those two arrows look the same length?
No.
No. So which one looks balanced then? I don't think that one looks balanced. It's close, but not exactly. There you go. Right. Okay. How about another one before I have to take off and help some other people? What causes a moving object to change direction? Oh, now wait a second. How do you get something to change direction? If it's moving a certain direction, what do you have to do to get it to? Yeah, you have to apply a force. Yeah, so click force. Okay, you're supposed to calculate FG. What's the equation for finding FG? I'll give you a hint. FG equals. Okay, Jacob, I have to go to other groups. Okay, so keep working. Sorry, I was helping other people. Josh, you want to share your screen with me so I can see the one you're looking at? That's hard time. Did you get that one to work out, the one triangle?
Not all of it. He got to the, he did the a squared plus b squared, but that's the.
Okay, so when you did the a squared, that would have been 25, right?
Yep.
Okay, then b squared is 49, right? Yeah?
74.
Okay, so then you added it up. Now you have 74 equals c squared. Do you remember what do you have to do to get rid of the square?
Divide it.
No, you have to take square root. Do you remember what the square root looks like?
No.
Okay, so you got to look here at your screen because I'm going to draw it for you. Okay, there's a symbol on your computer that looks like, or on your calculator that looks like, uh-oh, too close. It kind of looks like this. It kind of looks, Josh, can you look here? Kind of looks like a little, it looks like a little check mark house-like thing.
Yep, that's it right there. Yep.
So now you need to do square root of 74. Can you go ahead and do that? And I'm going to do it too. What do you get? What do you get?
You gotta press second to get it.
Oh, okay.
And then 74. And enter. Oh, you must have got, hold up, let me do it. 4 equals, there you go. That's your. Okay, sounds good. 8.6.
That's it. That's right. It's 8.6.
Oh, there it is.
Hey, Josh, I have another way for you to figure it out. Can you look at me? You got to look at the picture of me. Okay. Okay. So I'm going to move this way. You can actually figure this out just by imagining. Can you look at me? Imagine that you were hanging kind of like this, right? With one arm out horizontal and one arm right up here holding you. Imagine like if you fall, you're gonna plummet really far and you're gonna get hurt, right? I want you to think about which arm is gonna be more likely to let go because it's so hard to hold on. Is it gonna be the one straight out? Or is it
upwards?
That's right. You got a lot more weight on that one. And if you look at the numbers, do you see how the biggest number there is 8.6? Because it has so much weight on it. It has to be more than 7 or 5. Has to be more than 7 or 5.
Okay. Yep.
Okay? That's another way to kind of figure it out too.
Okay. Yeah. You say you got another question too.
Yeah. Yep. Another one.
What number?
10.
Can you show me? Can you scroll down? Okay, so hover puck turn on, moving to right is constant, pull to right. What's the net force? Okay, so wait. Force on the puck from the hand. Oh, I totally get why you did that one. That totally makes sense. Josh, can you look at me for? So I totally get it, but could you look at the picture? Look at the picture. The finger is not touching the puck. What's touching the puck?
String.
That's right. What kind of force goes through a string? What kind of force goes through a string?
Which one do you think? This one right here. Attention.
Bless you.
So you guys speak louder, Frank.
Attention.
Tension. That's right. So can you look right down to below the one that you picked? It really should have been tension. So your answer would have been right if the hand really would have been touching it, pulling it. So if the hand's touching it, pulling it, that would have been totally right.
Gotcha. Yeah. So just a simple mistake then, Josh.
Yep, that was a little one.
Okay. Is that it, Josh?
Yep.
Okay.
Okay, I'm sorry I didn't get back to you right away. I had a lot of people. I'm gonna go check in with them, okay? All right.
All right. Thanks.
Yep. So Jacob, did you have any more questions?
Yeah.
Okay, can you share your screen at the bottom? Hit the green share. And then when a pop-up comes up, hit the blue share in the lower right. Okay, so which one we're looking at here?
This one's number 7.
Number 7. You got a piece of paper there?
No, but I can create one.
Okay, so whenever you do these, you need to have a piece of paper. You there?
Yeah.
Oh, okay. So what I need you to do is we have to draw a force diagram. Okay. So there's going to be 2 forces on this diagram. There's going to be one force downward. So go ahead and draw an arrow downward and label that FG.
All right.
And there's going to be one force upward, but it's got to be a shorter arrow. So this arrow you draw upward, don't make it as long as the one that was downward. And label that force of, let's call it lift, force of lift. Okay. So now it says it's a 950 kilogram helicopter. How do you find FG? What's the equation? FG equals what? Okay, I got to go help Kari. Okay, so which one am I looking at here?
I did a couple.
Okay.
I did.
Oh, you want me to check the ones you had?
Yeah, so I think I did number 5.
Okay, no force is applied to a moving. It will continue to move a straight line. No, that's true. If there's no force applied to it, so there's no force. That means no friction, nothing. It's
I
gonna
thought it
keep
would
on.
have slowed down.
Well, no, that would, if there's friction, that would be a force being applied. So they're saying there's no forces applied to it, like a hover puck. No forces applied to it. It's going to keep on moving in a straight line at constant speed.
Okay. And then I didn't do number 6, 7. I did number 10.
Okay, hover puck is turned on. It's going to, how many forces act on it? Okay, so it's going to have a weight force down. It's
Mhm.
going to have a push force from the air upward. It's going to have a string to the right. What other force? So that's 3. What other force are you saying there would be on it?
Tension.
Oh, wait a second. Let me say them again. There's a force of gravity down. There's a push force upward. And then, yeah, there's a tension to the right. So that's 3. What other force?
Uh, Gravity.
I already said that one.
Oh.
Gravity force down.
Then I don't know.
I think
But-
it's just 3 then.
So I still need to do 6.
Okay, so let's look at this one. Find the acceleration. Okay, so for this one, the normal force and the gravity force are going to balance. But look at your picture there. The friction force is not as big as the pull force. So it's going to definitely accelerate, right?
Yeah.
So what will the net force be? If you can look at me for a second, you have 15 newtons this way, and you only have 5 newtons this way. What will you have to do with those two numbers?
Subtract.
That's right. 15 minus 5 is
10.
10. And now we have to find the acceleration. So do you have a piece of paper?
I could get one.
Yeah, you should always have a piece of paper when you're doing these problems.
Okay, 1 second. I found one.
Okay, so on your piece of paper, write F net equals ma. Did you do that?
Yep.
Okay, so right under the F net, we know what the F net is. We just calculated, but that was 10. So
10.
put 10 equals, and look at the picture. What's the mass?
5.
Right, so put 10 equals 5 times A. So how do you solve this for A?
You want to divide?
Yeah, divide both sides by 5. So what's 10 divided by 5?
2.
2. That's the answer.
So for
Oh,
these
sorry.
type of problems, I'm always just gonna subtract the pull force from the friction force.
Yeah, to find the acceleration, yeah.
Okay, I
Yeah.
see.
Or let's say if it would have said, what's the net force? Yeah, you still subtract and you got 10 for that.
So then if I'm trying to find the
Let's say FG.
yeah, so if I'm trying to find like the FG, I do FN minus FA.
No. If you're trying to find FG, you use the other equation. So write this equation down. FG equals M times 10.
So you said FG equals what?
M times 10.
Times 10. Is there any other equations just to write down?
No, that's it. Those are the only two.
Okay.
Yep.
All right.
Okay, I'm gonna help. Oh, so don't forget to put the answer in there too. Yeah, let me. I have to check another. I'll try to come back. Okay, so Josh, yeah, did you have a? Oh, wait a second. Are you all done?
Yeah,
Hey, if you're all done, you don't have to. You can leave. That's it.
I can leave.
Good job. So see you on Monday. We're gonna have another
Yep.
one of these kind of thing. All right.
Yep. See you.
Bye.
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 David, I'm sorry. Did you need some help on any of them?
Yeah, and all of them.
Can you share your screen, the green share
Yeah.
button, and then a pop-up, hit the blue share. Okay,
I'm
acceleration.
not really good at any of these.
Okay, the acceleration object does not have to be in the same direction. Okay, so I want you to imagine you're applying a force to a box. So I'm applying a force to it. So there's a net force on it. It's going to accelerate, right? Okay, compare the direction that I'm pushing and the direction it accelerates. Are they in the same direction?
No.
Wait a second, I'm pushing this way. Doesn't it accelerate that way?
Yeah.
Yeah, I think so. Yeah. So the net force, remember the equation F net equals ma? They
Mhm.
have to be in the same direction. Okay, let me look at some of the other ones you answered up above. Let me check those out. Okay, so is this number 2? Okay, go all the way up to the top.
This is yeah.
Okay, number 2, this type of force is always transmitted. Yep, that's right. Okay, scroll down. Okay, let me look this one. So tension, let's see. Now, wait a second. So I don't think there's tension here because there's no rope. You have a person pushing, right? There's like it says a person is pushing down on an object. So there's no tension here. Yeah, it's a push force. So get rid of tension. So I agree there would be a normal, there would be a weight. But if you're pushing, now wait a second, before you move on, if you're pushing down an object and it's moving at a constant speed, that's right. There's something that's pushing back, and that's friction. There you go. Okay. This one here, the key word on this one says constant velocity, and you picked the right one. That looks good. That's constant velocity. That's balanced. Okay, let's look at this. What force causes? Oh, what causes a moving object to change direction?
I thought it was inertia.
Well, inertia is the tendency for an object to keep on doing what it's doing. If let's say something's moving, how are you going to get it to change direction? What are you going to have to remember the bowling ball challenge thing? How did you get that bowling ball to change direction? What did you have to do?
Push on the opposite side.
You just said push. What is push?
A force.
There you go. That's it.
This would be 50, I think.
That's it.
Yeah.
That's 50. Yeah.
I'm having trouble with these ones.
Okay, so let me ask you this. I have a feeling, I think I know why you're having a hard time. Do you have a piece of paper there? Because you can't do this in your head. It's impossible. You got to have a piece of paper.
I'm using the calculator thing on my computer.
I get that, but you have to draw a picture.
All right, grab some.
Yeah, get a piece of paper.
Oh, they're up there. Okay, I got one.
Okay, so on your paper, draw like a little square or rectangle. That's going to represent the shopping bag, okay? And put it like a stick person, and the stick person is trying to lift it upward, okay? So you got your picture. Now what you're going to do is you're going to draw a force diagram. So look at your picture. How many forces are going to be acting on that shopping bag?
2.
Yeah, only 2. So draw a force diagram. That's the dot with the arrows. So put a dot, and there's going to be an arrow downward. That's the force of gravity. And there's going to be an arrow upward, and that's going to be, I don't know, let's call that a lift or something, or push, or I don't know, whatever you want to call it. Here's my question. If you're accelerating upward, are they going to be balanced or unbalanced? David, are you still there? Uh-oh, I lost David.
They would be unbalanced.
They'd be unbalanced. So yeah, which one's going to be bigger, the one down or upward? Uh-oh, you're cutting out on me. Can you hear me?
Yeah, it's just my internet sucks up here.
Oh, okay, so I didn't hear you. Which one's bigger?
The lift.
Yeah, the upward one, right. Yeah, so make that one longer than the downward one. Okay, so now when you're drawing your forces, the one downward, that's FG. The one upward, that's F lift or something like that. FG, if it tells you what the mass is, 5.86, how would you figure out what FG is?
Times the die 10.
That's right. So the FG, the downward one, put 58.6. That's when you multiply that by 10, you get 58.6. Okay, to figure out how big the upward one is, we have to use the equation F net. So can you write off to the side, right? F net equals MA. Do you got that?
Yep.
Okay, so then right below the M, put 5.86 times, and right below the A, put 1.98. And now you got to get a calculator out and actually multiply those two. And what do you get?
116.
Wait, 106. Wait, try it again. 5.86 times 1.9.
5.86.
Yeah.
5.86 times 11.6.
Right. Now, that's not the answer. No, wait a second. So look at your force diagram. Remember the upward one is bigger? Well, there's no way it's 11.6. So you have to do 11.6 plus 58.6. So add 58.6.
70.2.
There you go. 70.2. That's the answer.
Hmm.
Okay. So for this one, let me read through.
I said this one was 50
Let's see.
last time.
37 degrees. That's the 3, 4, 5 triangles, right? So on your paper, can you please put a dot on your paper? We're drawing a force diagram. Put a dot and draw an arrow downward from the dot. That's FG, and make that 100. And then, can you look at me for a second? On your dot, have 2 arrows going kind of at angles like this upward. Okay, then can you look at me for a second? So on this one here, upward, can you make a triangle out of it? Make a triangle out of it. Okay. We know what that downward one is. We know that's 100, which means, can you look at me for a second? This part right here of the triangle that you just drew, that must be 50. Okay. And this is a 3, 4, 5 triangle. That side right there is the, let's see.
That'd be the 4.
I think it's actually.
I think it's the 4.
I think it's now. It looks like the picture. The picture is not really drawing the scale. I think it's actually the 3 side. So can you take 50 divided by 3, and I get what, 16.6 or so? Is that what you get? You're cutting out on me again.
It's 16.6.
Yeah, that's the 3 side. Now multiply that by 5. So times 5.
83.
That's what I think it is. I have to check in with some of the other people, okay?
Yep.
Okay. Let's see. The reason I pulled you out is because I kind of want to call an end to this. So let me get a real quick picture here of you guys. Let's see. Oops, my mouse isn't working. Oh shoot! Dang it! Sorry, my mouse is not working. All right, sorry. All right, so that's all the longer you need to stay. If you want to stay longer and I can help you, you can, but you don't need to stay any longer. I appreciate you do, Stan. See you on Monday. We'll do kind of another, we'll have like a quiz like thing on Monday, kind of like this where you can do it over and over again. All right, so see you, or you can stay and I'll try to help you, okay? All right, so if you're staying, I'm going to go ahead and open up the breakout rooms again. That way I can go in and help you individually. Okay, so that way people don't have to hear it all. Stuff. Right? So again, if you want to leave, you can. Let me open up the breakout rooms. And again, at any moment, if you want to leave, you can. Okay, so don't feel like you have to stay. I think I'm going to start with Amani. So Amani, did you need me to help you with anything?
Yes.
Or maybe look
I-
over some of your answers? Hit the share, green share, and then hit the blue share.
Okay.
All right, so do you want to scroll at the top and I can just look at all of them so far that you got? Okay, so let's see here. Accelerator does not have to be in the same. No, wait a second. If you're, imagine I'm pushing on an object, doesn't the force and the acceleration, aren't they in the same direction?
Oh, yeah.
Yeah, so it has to be, right? So, and yeah, there you go. Type of transmit. Yep, tension, good. Flip. Oh, what happened to the picture there? Okay, so
I sure.
hover puck is turned on, sitting on the floor. What's the net force? Well, first of all, wait. If it's turned on and just sitting there, will it be balanced or unbalanced, the force diagram?
It's turned off. Wait, it's turned on.
Yeah, it's turned on. It's just sitting there. Oh, no, you're right. It's turned off, but it's just sitting. Wait, that's turned off. Either way, it's just sitting there. Will it be
Okay.
balanced or unbalanced?
Unbalanced. Oh, balanced. It'll be balanced.
Balanced, right? So what would the net force? What would the net force be if it's balanced?
0.
That's right. So it's 0.
Oh.
And let's see. Gravitational. Yep, that's good. Keep going. Which of the following is causing excitement? Yep, good. Keep going. We had to find. Yep, good. Keep going. Okay, we say. What is the acceleration? Oh, so for this one here, you're using F net equals ma.
Okay.
Okay, and they give you the force 2.6, and they give you the mass, and you just solve for a. So why don't you go ahead and do that and tell me what you get?
So 2.6 divided by 2.5.
That's it. And then round to the nearest tenth. What'd you get?
1.04.
Yeah, and that rounds to 1.0, right?
Yes.
Yeah, okay. Okay, for this next one, you got a piece of paper there, hopefully?
Yes.
Okay, so for the next one, I need you to draw a force diagram. So I'm going to kind of describe it to you. Okay, so if you can kind of look at me for a second. So put a dot. That dot represents the top of that square where the strings are attached. Okay, and then on that dot, have an arrow going downward. That's the force of gravity. So Fg.
Okay.
By the way, they tell you what the Fg is. It's 100. So down there on your picture, put Fg equals 100 at the bottom. Okay.
Okay.
Okay, then this is what I need you to do. If you can look at me, you're gonna have two arrows kind of angled like this at the top of the dot, kind of going upward like this. Okay, label both of those T or something, or FT, tension.
Okay.
Okay, so these are actually, this is 37 degrees. That's 3, 4, 5 triangle. All right, so I need you to look at me for a second. This is balance, which means if it's 100 this way, I'm hoping that you can kind of imagine a triangle here. Can you imagine a triangle?
Mm-hmm.
On your paper, can you go ahead and draw that triangle in on your paper?
Mm-hmm.
Okay, so, oops, hold on a second. All right, so on your paper, if you can look here, this vertical part right here,
Mm-hmm.
that must be half of 100. So put 50 there, 50. Okay. And this is a 3, 4, 5 triangle. This side right here would be the 3 side. So can you please, on your calculator, take 50 and divide by 3 and see what you get?
$16.6
Okay. Okay, now before we go further, we want to find the tension, which would be the 5 side. So multiply that by 5.
Times 5.
Yep, that's 16 point whatever times 5.
Okay.
What'd you get?
83.3.
Yep, that should be it. So click that one. Okay, and let's see. Okay, a person has oh, that one should be easy, right?
Okay.
Okay, Kari asked to help, so I'm going to go to him real quick, okay?
Okay.
Okay. let's see, breakout rooms, copy. Oh, good. I can see. All right. So which you want? Hey, before you submit, let's go at the top, and I can see all of them. Make sure. Okay.
All right.
Okay. So, all right. So number one. Let's see. Normal. Good. Okay. Scroll down a little bit, so I can see the next one. Yep, that's good. Number. Yep, that's good. Two's good. Let me see the next one. Number three. Yep, that's good. Let me see the next one. Four. Yep, that's good. Let me see the next one. No forces applied to it. Consumer. That's true. Okay, keep on scrolling down. Let's see. Yep, that's good.
Still need number 7 and 8.
7. Okay. What is attention? All right. All right. So you still got that paper, right?
Yes.
Okay. So I want you to kind of draw a rectangle on that paper. That will be kind of like the bucket here. Okay. And on that bucket, I want you to have an arrow going, or not an arrow, like a rope going upward, a chain or something. So you got a bucket and you got like a little string going upward. Okay?
In the middle of it?
Yeah, kind of in the middle. Yep. Okay, now off to the right, we're going to draw a force diagram. So what I'd like you to do is put a dot, and then you're having, well, how many forces do you think act on this bucket?
It's being lifted upward by a chain, so it's going to be gravity.
Right? And
Weight. Would there be weight?
Yeah, gravity is weight. So what's something?
Oh, yeah. So gravity, tension.
That's it. That's it, too.
Okay.
So on your force diagram, have an arrow going downward, that's FG. And right here, it says it accelerates upward. So which one, will they be the same size? Will it be balanced or unbalanced?
It'll be unbalanced.
That's right. So if it's accelerating upward, which one's bigger, the tension or the gravity?
The tension.
That's right. So when you draw the arrow upward, make sure that one's longer.
Mhm.
Call that FT for tension.
Yeah.
Good so far?
Yes.
Okay, so now we need to figure out how much the FG is. Notice it says the mass is 44. So what equation helps you figure out FG?
M times 10.
That's right. So M is 44. So what's 44 times 10?
Calculator. 44 times 44. 440.
That's right, 440.
So the answer would be 440.
No, we're not done yet. So on your picture there, FG put 440. Down there at the bottom, put 440. Okay, now we want to know what the tension is. So in order to figure that out, we have to use the other equation. So on your paper, could you put F net equals MA?
Mm-hmm.
Okay. Again, right underneath the M, put 44. And look at the problem. What's the acceleration?
0.6.
That's right. So right under the A, put 0.6. So now on your calculator, do 44 times 0.6. What do you get?
26.4.
Right. Now, that doesn't make sense. That's not the tension, but that's right. What the tension is, it's bigger than the force of gravity. So if you look at your force diagram, it's bigger than 440. So you have to add 440 plus the 26.4. So 440 plus 26.4. What'd you get?
466.4.
That's it. That's the answer.
Okay. All right.
Okay. Okay. Actually, this is one of the harder ones. So let's scroll past this because we're running out of time. Let's look at number 9. So a person has a mass of 45 kilograms, and she weighs. How much does she weigh in the moon? Where G is 1.62. Okay. So what's the equation for figuring out the weight? FG.
M times 10.
That's right. But this time, instead of 10, we're going to use 1.62.
Okay.
So can you do 45 times 1.62?
$72.9.
Right. So which one's the closest one there?
73.
That's it. Okay, let's look at the next one, number 10.
Oops,
So-
sorry. Go down fast.
Okay. So, oh, you did that one. All right. Let's look at number 11. Okay. This contact with the phone being pushed. Is the magnitude of force. Oh, this one I shouldn't have. This is too hard. I shouldn't have had this one on here. Let's see. Being pushed by. All right. So I'm going to help you with this one because this was way too hard. Okay. So it tells you there's a push of 20 newtons on this whole thing. The mass of the whole thing is 10. So we're going to figure out what the acceleration is. So can you on your calculator do 20 divided by 10 to figure out the acceleration?
So just 2.
It's just 2, right? But it wants to know what's the magnitude of the force of the 6 on the 4. So now we need to take that 2 and multiply it by 4. What's 2 times 4?
8.
8. That's the answer for that one.
Oh, okay.
That one was way too hard. I shouldn't have had that one in there. Okay, 12. The car goes forward along the level. Now, the key word here is it says constant velocity. Okay, so balanced or unbalanced if it's constant velocity?
Balanced.
It's balanced, that's right. So it says the additional force needed to bring it in equilibrium. Okay, so if it's balanced, is it in equilibrium?
Equilibrium means that it's moving, that
Well,
it's
no, wait a second.
unbalanced.
No. Equilibrium means balanced.
Oh, okay.
Okay, so it's already balanced. So how much more force do you need to make it balanced?
0.
0. So the answer is 0 there. Okay, let's look at the next one, 13. So just look at the force diagram. Which way is it accelerating?
Well, wouldn't it not be accelerating because there's a rope?
Well,
Oh, wait, no, gravity's down, so it's going down.
No, wait a second. Look at your force diagram. Do those look balanced?
Yeah.
They do? They don't look the same size to me.
Oh, wait, the bottom one's a little bit bigger or smaller than.
Right, so which way is it accelerating?
Up.
Up, right. Okay, let's look at the next one real quick. All right, Space Pro. Oh, so we need to figure out what the, wait a second. All right, so just pick one randomly for this one because we're running out of time. Just pick one real quick. Well, you got 12 anyway, okay?
Okay. Thank you for helping me, though.
Yeah, no problem. See ya.
All right, see ya.
Okay. Sorry, I just got back here. Do you want to scroll up and I can look at some of the other ones you've answered since I was gone?
Yes.
Let's see here.
It started at number
Yeah,
9.
that's the one. So you got that one. Okay, so let's look at number 10 then. So we want to know how many forces. Okay, so tell me what forces you think act on it.
Normal.
Actually, that's not touching. So, but there is something that acts like normal. It's a push from the air. There's a
drag
push.
force for the air resistance.
Oh. Well, wait a second. When we did this in the classroom, remember when I gave it a shove and it just kept on moving at constant speed? It didn't slow down, right? It didn't slow down. So was there any drag on it?
Oh no. Okay.
Oh, okay. So there's no drag, but you're right. There is something upward, kind of acts like normal. That's a push from the air. So there's one. What else?
FG.
Yep, there's a force of gravity. And then look at the picture. What else? There's a string touching
It's
it.
pull. Pull. Push
But
pull.
Yeah, but it's through a string, so it's tension.
Oh, tension. Okay.
So how many forces?
3.
3.
Okay.
Oh, you didn't answer that one. What's the word normal mean? I'll give you a hint. It has something to do with some kind of angle. What angle is it? It's a special angle.
Oh man, I should know this.
It's a special angle you hear in math class all the time. It's an angle
A
like
90 degree.
That's right. And there's another word for it, perpendicular. So
Okay.
normal, perpendicular, 90 degrees, they all mean the same thing. So what's the right answer there?
Oh, right here.
Yep. Not describe force. Force is, yeah, that's true. Change, yes. Yeah, good. Looks good. 12's good. Okay. So it tells you the tension force is 12 newtons and the friction is 41 newtons. That kind of makes sense. It looks like in the force diagram it's bigger.
Mhm.
We're trying to figure out the acceleration. Okay, so we got 41 newtons this way, huge, and we got a little forward force this way, 12. What would you have to do with those two forces to figure out the net force?
Multiply them.
Wait a second, they're in opposite directions. 41.
Oh,
Well,
divide them.
no, wait a second. They're think of it as like money. You got $41 coming in and you got $12 going out. How much?
You subtract.
Yeah, you have to subtract them. So what do you get?
$29.
Okay, so that's the net force. So you got a piece of paper, right? So write F net equals MA.
That equals MA.
Okay, and right below the F net, you just found the net force was 29. Look at the question. What's the mass?
8.
8. So now you have 29 equals 8A. How would you solve that?
Divide by 29.
No, you want to divide by 8.
Oh, divide by 8. Okay.
What'd you get?
3.625.
Yeah, but you have to round to the nearest hundredth. So what would that
So
be?
3.6.
3.63.
Oh, okay.
That's not. Okay. So what's the equation for force of gravity?
F equals 10 times the meters per second
No. It's Fg equals m times 10.
Oh, okay.
Okay. So, but in this case, that 10 is only on Earth. In this case, instead of 10, it's going to be what number?
1.363.
That's it, right. So can you on your paper put Fg equals m times 1.63? Fg equals m times 1.63. Okay, right below the Fg, they tell us what the Fg is. It's 117. So put 117 equals m times 1.63. So how would you solve this?
Would you divide by 117?
Now you got to divide the other way. So here's how you figure it out, Amani. You're right. You got the division right. That's good. But you're trying to get the m by itself. That means you got to get rid of the number that's with the m. So you have to divide both sides. Yeah, you have to divide both sides by the 1.63.
Okay.
What do you get?
17 divided by 71.779.
Yeah, so which one of those is closest?
72.
Yeah.
Okay. Okay.
Yay. Oh, you got, oh yeah. Oh, I thought you did it more than once. Yeah, nice. Okay, cool. Is there any that you missed you want to go over?
From my last one?
Yeah, if you want to. You don't have to. I just didn't know if you had any questions.
Oh, yeah. Okay, so sometimes I do get confused
Okay.
on, show you the ones I missed. Like number 7.
Okay, so so on your piece of paper there, can you draw like a you know, like a little car, or maybe draw a square that represents a car.
Mm-hmm.
Okay. And we're going to draw a force diagram for it. Okay. First of all, notice it says that it accelerates. Will it be balanced or unbalanced?
It'll be balanced.
No, it's going to be unbalanced. If it accelerates, it's unbalanced.
And if it like doesn't accelerate, it's
Right.
balanced.
Yeah. So if it's just sitting there, it's balanced. If it's moving at a constant speed, it's balanced.
Okay.
But if it gets faster, unbalanced. If it gets slower, it's unbalanced. Or if it changes directions, it's unbalanced.
Okay.
Okay. So for this one, it says it's accelerating, so it's going to be unbalanced. Okay, so let's draw a force diagram. So off to the right or left, put a dot, draw an arrow downward, that's going to be FG. Draw an arrow upward, that's going to be FN. Those two are balanced. Those are the same size, FG and FN. It says there's some friction or something. So have an arrow going backwards, you know, to the left or something like that, and label that F friction. And then we need one more arrow opposite the friction. So let's say to the right, and that one's going to be longer than the friction. And I don't know, let's call that one F push maybe. Okay. So it tells us what the mass is, 2058. How would you find what FG is? What do you have to do?
Multiply by 10.
That's right. So 2058 times 10.
Oh man.
What'd you get?
Oh, no.
Oh, you're cutting.
20,580.
Yep, that's it. So on your force diagram, where the FG is, put 20,580. And then FN is also 20,580.
Okay.
If you look at the problem, it tells you how much friction there is. It's 1881. So on your force diagram for friction, that's the arrow to the left, right? 1881. We want to know what the arrow to the right is. In order to figure that out, we have to use the equation F net equals MA. So put F net equals MA on your paper. Okay, what's the mass again? Look at the problem.
2,058.
Yeah, so so you have F net equals MA. Right under the M, put 2058. And look through the problem again. What's the acceleration?
2.1.
2.1. So put right under on that equation, F net equals MA. Right under the A, put 2.1. So what's 2058 times 2.1? What'd you get?
4,321.8.
Right. Okay, so that's how much bigger, I should say. That's how much bigger. What you just calculated is how much bigger the push force is than the friction. So if you want to know how much push, that's what we're trying to find. You have to take that number you just found, 4,321.8, and you need to add how much friction there was. And the friction was 1881. So take 1881 plus 4,021.8.
Okay. 6,202.8.
That's the answer.
Okay. Okay. That's like the only one I was really confused on. You helped me with the other ones.
Okay, cool. Well, thanks for staying, and I hope that helps. And then Monday we're gonna kind of do the same thing, except I don't know exactly how much I'll be able to help. I'm hoping Mr. Alger can come and kind of help us out too. All right. Thanks for coming. I'll see you later then. Bye.
Bye.